Welcome to SAT 021. The topic of this lesson is linear inequality system. When there are two variables in a linear inequality, it can be written as ax plus by is greater than c, where a, b, and c are real numbers. And the inequality symbol can be greater than or equal to, less than or equal to. An ordered pair x, y is a solution of a linear inequality in x and y if they make the inequality true. Okay, so we need to test if they make the equality true or not. So let's look at some examples. So these are 3 points, and we're going to test if they are solution of the linear inequality or not. Okay, so we're going to substitute x equals 1 and y equals 1, and we get the left side is 1, and is 1 greater than or equal to 5? No, it's not. So 1, 1 is not a solution of this inequality. So the conclusion, it's not. The second one, substitute x equals 1 and y equals 2 into the inequality on the left side, and that's 5. And is 5 greater than or equal to 5? Yes, okay, it is true. So 1, 2 is the solution of this inequality. The third one, substitute x equals 1 and y equals 3 into the inequality, and we get 9 is greater than or equal to 5, and it is also true. So that means 1, 3 is a solution. Let's look at a practice question. Which of the following xy is a solution of the system of inequalities y is greater than or equal to 3x minus 1 and y minus x is greater than 1? And there are A, B, C, D, 4 choices. And actually these 4 choices are 4 points. And we are going to test them in both inequalities. Okay, and remember, the x and y value, when we substitute them into the both inequalities, they must make both inequality true. Okay, not just one, both of them. And if they make both inequality true, and then that's a solution. If not, then it's not a solution. Okay. Okay. So the first one, x equals 1 and y equals 2. Substitute them into the first inequality. It is true. And then the second one, no, it's not true. Since 1 is not greater than 1. So A is not the right answer. The second one, substitute x equals 2 and y equals 1 into the first inequality. No, it's not true. So 2, 1 is not even close. Okay, there's no way. But if we still test the second inequality, it's not true as well. And then substitute x equals -3 and y equals -2 into the first inequality. It is true, okay, because -2 is greater than or equal to -10. And then the second one, no, it's not true. Okay, same reason why 1 is not greater than 1. Okay, so C is not the right answer. So it must be D, right? Since A, B, C are not correct. But still, let's double check. Substitute x equals -5 and the y equals -3 into the first inequality. It is true. And then substitute into the second one. It is true as well. So the correct answer is D. Okay, so now to graph a linear inequality, there are several steps to follow. And we're going to learn this together by looking at one example. So y is greater than or equal to 3x minus 1. Okay, so we need to graph it in the xy coordinate. All right, so step one. Step one, we're going to change the inequality symbol to the equal sign and graph the line. So we change this inequality to y equals 3x minus 1. And this linear equation is in slope-intercept form, right? So you can plot 0, -1, which is the y-intercept, and then use the slope 3 and rise over run, rise 3 and run over 1 unit to the right to find the second point. But anyway, this is the graph of it. And remember, this is a solid line. Okay, so that means any points on the line are solution as well. Step 2, test a point in one of the two half planes. And we are going to test normally, first choice, 0, 0, the origin. Why? Because 0 is an easy number. Okay, so we test 0, 0, and then yes, it is a solution. Okay, it makes the inequality true. And then, So step 3, we're going to shade the half plane with the point as a solution, shade the other half if not. Okay, so we're going to shade the half plane with 0, 0, which we just tested. Okay, so in this case, it's the half plane on the left. Okay, so this half plane is the solution of this inequality. And also remember, on the solid line, any points on the boundary are solutions as well. Okay, so let's look at another example, and we're going to graph on the same coordinate plane. So y minus x is greater than 1. Okay, so step 1, same thing. We're going to change the greater than symbol to equal sign. So y minus x equals 1. So this linear equation is in standard form. So the best way to graph this equation is to find x-intercept and y-intercept, or you change it to slope-intercept form, your choice. But anyhow, you're going to graph a line like this. Now, realize there's no equal sign in the original inequality. Okay, so y minus x is greater than 1. There's no equal there. So that means you need to graph a dashed line. In other words, the points on the line are not solutions. Okay, excluded. Okay, so dashed line if there's no equal in this in inequalities. Okay, remember that. And then step 2, we're going to test a point on one of the two half planes, and then we're going to test 0, 0 again. And 0, 0 in this case will not make this inequality true, so it's not a solution. Okay, and then step 3, we're going to shade the other half of the half plane if 0, 0 is not a solution. Okay, so we're going to shade the upper half plane without 0, 0 in this case. Okay, it's the green one. And then the overlap area is the solution of this system. Okay, and also look at the boundary. Dashed line is not a solution. A solid line, it is solution. And here, the solution, you can see part of it is solid line, and part of it is dashed line. So be very careful. Okay, so now we're going to test 4 points, and that's the 4 points in the previous slide. Okay, so that's pretty much the same questions from the previous slide. We can see the point in the overlap area, -5, -3, is a solution, right? Confirmed. It's choice D from the previous question. And then moving to the right, -3, -2, it's on the dashed line. Okay, so it's not a solution. And then moving further to the right, 1, 2, it's on the dashed line as well, so it's not a solution. And then the last one on the right, 2, 1, is far off. Okay, it's not even close. So that's not a solution. Okay, so confirmed. The question from the previous slide is D, -5, -3. Okay, so let's look at one more practice question. Mabel is a one-on-one tutor who answers mathematics questions and helps students around the world overcome their fear towards math. She can answer 2 types of questions, in algebra and in geometry. She charges $5 for each algebra question and $4 for each geometry question. Her goal is to answer more than 60 questions and make at least $250 each month. Let X be the amount of algebra questions and Y be the amount of geometry questions. Write a system of inequality to reflect Mabel's goal. Okay, so first, X for algebra question and Y for geometry question. Okay, so keep that in mind. Then her goal is to answer more than 60 questions, more than. Okay, so that gives us the greater than sign. Okay, so X plus Y is greater than 60. So the total amount of algebra and the geometry questions is greater than 60. Okay, and then she charges $5 for each algebra question and $4 for each geometry question. And she wants to make at least, okay, at least 250, at least give us greater than or equal to. Okay, so at least give us greater than or equal to this inequality symbol. So greater than or equals to 250. Now, 5x is the total amount Mabel will earn from algebra questions. Okay, 5 is the unit price and x is the amount of algebra questions. And 4y is total amount of the money she will get from geometry questions. Okay, 4 is the unit price of geometry question, and then y is the amount of geometry questions. Okay, add them up, greater than or equals to 250. Okay, so that's all for this lesson. Thank you for watching. Goodbye.